Hey, Richard. How's it going?
It's
Nice
going,
to be here.
it's going well. Always good to be with you.
For the folks who are joining us for the first time, we keep doing these webinars pretty often at Traceable. But if you haven't heard from me before, I'm Amol. I'm a product manager at Traceable, and I've been here for about a couple of years. Really excited to be in front of you and talking about our topic for today, which is API governance. Richard, if you want to introduce yourself.
Absolutely. Richard Bird, I'm the Chief Security Officer for Traceable. I actually very excited about today's topic, which is weird because how can you be excited about something like governance? But I've actually been doing it operationally for a long time. I spent 20 plus years in the corporate world before I came to solutions about 5 years ago. And I've been with Traceable for just about 8-ish months or so now, and really like to see the evolution of what's happening within APIs, not just within security, but also within topics like governance. So really looking forward to the conversation.
Thank you. That's awesome. So with that, let's dive in. For the folks who've joined us, the format of for today's webinar will be we'll have a chat with Richard. We'll use the opportunity to talk to him about what he's seen in the industry over the years, especially around the area of risk and governance and how it relates to the APIs. And we'll follow that by a presentation around risk-based governance for APIs, which will focus on what we are seeing at Traceable from our customer base, how we're seeing the world evolve given our interactions with analysts, auditors, and so on. So with that, Richard, I know this, and you've already mentioned this, that you've been in the industry for 20 plus years. How have you seen this governance field evolve? It's a pretty loaded word.
Yeah, it is. And I think we, like a lot of the subjects that I get a chance to talk about here at Traceable, sometimes I feel like I'm the archaeologist and anthropologist of old use cases, but old patterns always repeat themselves, right? And I think the governance topic is really, really interesting because it's not new in technology. From a kind of a writ large standpoint, governance kind of really started to come into its own in the early 2000s, and it was heavily oriented towards initially towards the identity control plane within security, and governance was about who owns what, who's responsible for what. Are there identified owners for these assets and those assets? And then governance gradually started to evolve into other aspects of IT operations and management, inclusive of, but not exclusive to security. And when we think about things like CMDBs, there's a time in our technology history when our assets were very poorly understood and very poorly documented. And we saw the rise of companies that really focused on the creation of asset inventories. And when asset inventories really started to get developed, the demand for governance quickly, either was parallel to, those asset inventories or quickly developed after, because for a long time, things like when we think about a service now as a CMDB, for a long time, the practices that were used by technology organizations were they'd identify those assets to meet audit requirements, but then there was no evergreen process. And so you ended
Right.
up with really, really stale information. So you started to see a lot more discipline being put into governance, driven by initially by audit and compliance demands. But we look at that evolution, it almost seems inevitable, that we would see expectations around APIs as it relates to governance, because we're looking at the same situation, which is there is a need for ownership, there's a need for an assignment, there's a need for the maintaining of the information about those APIs. And that's where we're starting to see governance really come into its own as an expectation in API management, API operations, and API security.
Yeah, that makes sense. And one interesting bit there where you contrast it with the other types of assets that used to be manually either uploaded in the asset inventory or had tools. Those assets didn't change as much as the APIs do. APIs are very ephemeral. Plus, with the distributed model where there are many, many teams compared to this one centralized security team, many developer teams that are producing APIs, one centralized security team that's still true in a lot of cases. One centralized team responsible for securing all those APIs, it becomes exponentially hard for them to gain visibility at all.
Yeah.
Who's producing what? Yesterday, I had 500 APIs in my system. Today, I am 505. And by the way, of those, not just 5, about 50 of them are new, 40 have been deprecated, so on and so forth. So how has the governance field changed, or how does the governance field need to evolve to keep that into account? We take that into account.
Well, when we look at the API control plane specifically, it does raise a tremendous number of concerns and problems, many of which you just highlighted, which is APIs, unlike if we think back to the days of landed assets, right? APIs, as opposed to a server, an actual device, when we think about that, the changes associated with that device were not as dynamic or as energetic as the potential for changes within a single API, let alone an entire inventory of APIs. And so I think that I always phrase the technology evolution conversation in terms of speed and volume, all right? And when we look at APIs now represent the maximal amount of speed and volume available in the technology landscape. A server, was landed, was understood, had an OS, had the data elements that were associated with its usage. It was easy to define. An API has the capacity for tremendous amounts of business value to be unleashed, even with just one API. But with that comes a tremendous amount of flexibility, agility, adaptability for that API to be used across a growing landscape of applications and data sources that it can reach into. And because of this really, really dynamic nature of APIs, it's critically important as a part of the API governance process to understand the risk dimensions of these APIs. When we start to talk about that, we're starting to talk about a different approach or an additive approach to governance, which is associated to the context of these APIs. I want to pause for just a second because you said governance is a loaded word. Context or contextual security is very much a loaded word.
Right.
Here at Traceable, we take great effort to define what we believe contextual security and context for APIs means. And we actually use an old model for this. We actually use what's called the Kipling method, which is who, what, where, when, and why. And the idea is if you do not aggregate the information about these APIs, not just the scripted responsibility or the scripted design of the API, the DNA, what it's supposed to do, but where it's actually accessing, what it's actually being used for, who's actually leveraging it, why it is being used, say, in this particular instance or this particular use case. If you don't have that rich information about it, you have an incomplete inventory. And if you have an incomplete inventory, it is impossible to have disciplined governance. So we believe that the API governance conversation is actually the melding of each of these three pieces. And there really hasn't historically in technology been much attention paid in terms of inventories and governance to the contextual space. So if I was going to say that there's something that's being added to this mix that really hasn't existed in prior iterations or historical patterns, it would be this notion of context.
Makes sense. Context is certainly overloaded, and thank you for diving into it and teasing that apart for us. Going back to the CMDB idea, the other thing that seems different to me is CMDB initially, when it came about, was an asset inventory software for the teams that were required to manage those assets. For example, if I had X number of machines in my office, I, as an IT ops person, was responsible to make sure that the operating system was upgraded and it was on the latest version, patched version, and the one that was approved. In today's world, APIs are not being managed by security. They're being managed by the developers themselves. They are the ones that are responsible for making sure that they are upgraded, any vulnerabilities are taken care of, they're accessed properly. But security teams are responsible for making sure that the attack surface management is properly looked after. We have the right set of controls, firewalls, posture requirements are met, and they are the ones that are answerable to the audit teams. So this division of responsibility is interesting because it makes for an interesting dynamic between the two teams, especially for the governance area, where developers might see that as an overhead, but security teams, this is their primary focus sometimes. Would you agree?
Yeah, I would definitely agree that that is current state, and I have a feeling that this whole talk track that I always have about patterns repeating themselves. I have a feeling that we're actually going to see a change that happens in this API management, API operations, API governance space that's going to be more reflective of what we've seen in history. So the example that you just gave is really interesting to me because we experience these same problems when, say, application developers, let's go back about 15 or 18 years, application developers are managing their own authentication calls. Application developers were managing their own leveraging of encryption stores, right, for applying encryption keys to their particular application or their particular data needs for that that purpose, and that didn't work, right? That actually ended up not turning out too well, and we started to see more of a segregation of duties.
Right.
Initially that segregation of duties was forced upon that equation. I remember, some 20 years ago, I remember a lot of screaming and yelling about you can't take my authentication calls away from me. And so I can definitely see that this whole notion of an asset inventory and ownership and assignment could ultimately change and be more reflective of what we've seen previously, where there's an acknowledgement of segregation of duties. Because you know this better than anyone, Mo, the power within an API that has associated encryption is just as powerful as any other type of access token or capabilities that have previously existed in the application space and in the networking space as well. So the idea that application developers are going to continue to be able to operate, DevOps will be able to continue to operate without any securitized friction around the assignment and ownership and the management of these APIs seems to be like not the way that the model is going to go. However, I want to kind of bring it back to what you were highlighting, which is this brings up the big question of who owns APIs.
Right.
And I think that the answer to that question today is that that question is currently unresolved, and it is done a different way in as many different companies as you and I interact with and talk with on a weekly basis. I don't think it will stay that way for long, but that does beg the industry to take a lead in creating the mechanisms for both the evolution and the maturity of governance with APIs, because we have to be acknowledging the fact that the reality is we are probably trending towards that future state that I was talking about, even though we're in the current state that you opened up the question with.
Yep. And it'll take some time. We are seeing evidence of this convergence happening. You're seeing the development teams at Traceable and also at our customers becoming way more cognizant of security, good security practices at the time of coding, at the time of checking in, at the time of building, way before the code hits the deployment environment. That's definitely happening. I've seen that change massively in my career. I wouldn't bet against you, and I wouldn't bet against you. And I think what you're saying will happen sooner. With that, let me pause here and switch to the presentation as we talk about risk-based governance for APIs, which is the topic for today, and how this field has evolved and what our point of view is. All right. So, like Richard and I were just chatting about, I don't think it will be a surprise to anyone here on the call that the API attack surface area is growing. Once we move our application architecture from whatever it has been to an API-driven architecture, it only goes one. And that way is where the number of APIs continue to increase in your environment. Now, the developer teams are often in large companies decentralized and move at their own different paces. The security teams are centralized, and now the security teams are responsible for managing this vast attack surface area that's continuously growing. Here are some stats on the screen about the number of attacks that are API related that have happened recently. The ones that jump to memory are the ones, the recent attack that happened at Optus in Australia, the T-Mobile attack, Shopify attack, and the one that happened. And if you are operating in an industry that is more regulated than others, such as finance or healthcare or some of the other ones, you've probably already realized that the requirements are more stringent there. The downsides of an attack are more devastating. One thing that people don't realize often is when we say that attack surface area is growing, about 83% of the API traffic, of the web traffic, flows through APIs. This is a statistic which was true as of 2019. So in 2023, if today that number has, in all probability, just grown. Even if you're accessing your web app through a browser, most of that traffic is being carried to the backend servers through the API, and from the backend gateways to the services, to the data stores, and then back to the users. The transport mechanism is the API. So it's widely important to make sure that the APIs are secure and they're governed. But what do we mean by good? The term is overloaded, like we were discussing a few minutes ago. It has evolved over time, but it also means slightly different things for different types of persona in a company. If you're on the engineering side, maybe you're an architect, maybe you're a technical lead, maybe you are an engineering manager. API governance is about making sure that the architecture that is used to build different APIs in different teams is consistent. You are coding your APIs in, if not the same, at least those 2 or 3 approved languages. You are deploying them on the same gateways. You don't want to be in a situation where 10% of your APIs are managed by MuleSoft, 10% of your APIs are managed by Apogee, 5% of your APIs are managed by some other gateway, and then the rest of them are completely empty. So the governance for these teams mean the ability to prevent redundant APIs, making sure that the code is reusable and is of high quality, and enforcing consistent design principles so that new teams, new APIs that need to be developed can, 1, be released to the market sooner, 2, are more secure, and 3, are reusing any piece of code that is available. Now, from the IT operations point of view or a security administrator point of view, API governance has traditionally meant IGA, which is, making sure that the identity and access for the person that's using the APIs or going to use the APIs is controlled, and the right set of people have the right set of access to both the APIs and the data. Making sure that the governance exists in this area will make sure that the automation and the operational cost is reduced. The security administrator and the IT ops people have a centralized view of who has access to what resources are being used, what data is being accessed through which API, and making sure that the controls around those exist. This is very useful for compliance and audits. Multiple audits that happen within a year ask for this data. From the product security point of view, which is of particular interest to us today, comes the risk-based governance of APIs. And what we mean by that is if you don't have a continuous posture to analyze the risk for your APIs that are underpinning your applications, both web and internal, and you don't have a way of monitoring releases regularly, and there are unplanned releases that go out, that just means that you're opening up yourself up to the kind of attacks that we talked about in the previous slide. So having a governance framework from a product security point of view means you have a sense of risk posture for all your APIs. You can identify deteriorations to those risk posture due to planned or unplanned releases, catch those deteriorations as far left as possible at the time of checking in or at the time of building, if not certainly at the time of testing, before those APIs are moved to production. And you're also able to associate the right owners with the right set of APIs for any actionability, any actionability that comes out of your testing, scanning, such as vulnerabilities, such as sensitive data risk, and so on. This ownership piece is very similar to the IGA conversation we just had. In fact, these three areas are not mutually exclusive. There's a decent level of overlap in terms of the functionality that these three personas within the company are looking for. So for today, we'll focus on the pain that the product security folks feel, and how risk-based governance can alleviate a lot of that. So if you're new to risk-based governance, or if you're just starting on your risk-based governance journey, typically when we see our customers embark on this, these are the different milestones they hit. The first and the foremost thing you have to do is get a sense of what's the scope for this project, how many APIs exist in your system. And it's not enough to just get a snapshot of the APIs that exist in your system today. You have to put tooling and procedures in place so that this API discovery is continuous, and at any moment in time, you have an up-to-date inventory of all the APIs that exist in your system. The next level, once you've established a baseline for all the APIs that exist in your system, you understand which of these are internet-facing, which of these are internal. You understand other types of classification around these APIs, such as what protocols are being used, approved protocols are there. The next thing to do is to make sure that you identify owners from these APIs. Because once you find any issues that you need to remediate, or any concerns that you need to talk to more about, you need to find the owner. And this is not a trivial thing. I want to spend a minute on this, because oftentimes folks will walk past the stage into the analysis of risk scoring and coming up with a risk score and having a prioritized list of issues that they want to go after, only to realize that all the issues that you've discovered and maybe created in issue tracking tools are sitting without any owner assignment. Imagine if you're a security team that's responsible for making sure your APIs are secure in a large company with hundreds of developer teams, and a scanning tool or a testing tool just created 400 Jira tickets for you. And you are now responsible for, one, triaging all those issues and then assigning them to the right person. That's an uphill battle that I guarantee you those 400 issues will sit there in the queue for longer than they have to. And a lot of them won't get the level of attention they deserve. So it's absolutely important to have ownership of APIs and be able to make sure that that's up to date. Then, once you've discovered all your APIs and you've established ownership for your APIs, making sure you understand which of these APIs carry sensitive data, either back to your users or to your partners or other third-party APIs. There's a lot of attention that's paid to data at rest and making sure that we are able to identify which of the sensitive data at rest is high severity, low severity, etc. Not enough attention is paid to data in motion, which leads to a lot of data exfiltration pipes attacks, bots being super active in your environment, and so on. The next thing to do is make sure that you have a handle on all the shadow APIs that exist in your system. These may be APIs that have come about due to unplanned releases that were not advertised in advance, or due to APIs that don't follow the right protocol, the right guidelines, are not deployed on a gateway, and are either directly accessed or indirectly accessed. These shadow APIs pose a grave threat to your environment. So it's critical that you understand what APIs in your environment are shadowed and then you can track them towards a healthy state where they're managed through a gateway and have the right set of controls on them. Finally, some of the things that I talked about, and I'll go into this in a lot more detail, feed into this risk scoring mechanism that scores each of the APIs based on how risky they are and the impact they have to the business. That helps in prioritizing issues that are discovered during governance, making sure that when you go to the auditors, you can tell them the plan for getting back into a healthy state. And so finally, like I mentioned before, this cannot be a snapshot in time. This process has to be continuous and has to be supported by tools that can do all of this. And if not all of this, a lot of this in an automated fashion, because if you don't have that, doing this manually is a very, very tedious task. Some examples that we've seen where lack of governance caused issues were, in recent memory, two jumped to mind. One was an issue where someone was investigating whether SSN was actually being returned by an API or not. They changed the configuration of the API from HTTPS to HTTP in order to debug the issue, realized that the issue was there, fixed it, deployed the change back to production, and forgot to update the configuration back from HTTPS to HTTP. Lo and behold, bots discovered this new endpoint, and they were able to exfiltrate large amounts of sensitive data that was being sent back through this API. If you had continuous risk governance, you would have identified that an existing API was updated. But more importantly, the risk score of that API due to the update deteriorated. And it deteriorated because the state of encryption changed from true to false. And this could have been detected in staging and fixed in staging or development before being deployed to production. Another example that comes to mind is the case of two different gateways, both of them identical in most aspects, except one of them is meant to be hosting external-facing APIs, internet-facing APIs, the other hosting internal-facing APIs. And the developers across different teams, not just one, by mistake were publishing internal APIs on the external-facing gateway, external APIs on the internal-facing gateway, which was creating a major posture risk. With continuous governance, customers can enforce the ability to separate controls for internal and external endpoints, alert when an internal-facing API meant to be only consumed by internal users is deployed in a fashion where it's accessible externally, and the risk score is high. Those are just two of the examples. There are many that we see day in and day out, and I'm sure you've experienced some of this yourself. So we've talked about risk, we've talked about risk score, we've talked about the importance of risk score, but what is it? Unlike other standards in the industry, such as vulnerabilities, such as what is considered sensitive or not, there isn't a standard for risk. And I've had many conversations with analysts in different forums, and they all feel that this is one of those things that needs to be addressed at an industry level, but hasn't yet happened. So, in a common day-to-day language, all of us understand what risk is. We know that an API is risky, meaning an API is more susceptible to attack. The chances of that API being attacked is extremely high or easier than others. And the second facet of risk is if it were to be attacked, the impact of that attack would be much higher compared to the other APIs. So that's actually, that mental model is what we've tried to incorporate here at Traceable also. Risk score for us has two dimensions: likelihood of exploit and impact of exploit. Things that factor into the likelihood of exploit are: is your API encrypted? Is your API authenticated? Is your API accessible over the internet? And does your API have any vulnerabilities? Now, all of these factors have different levels of controls. An authentication could be non-existent or could be weak, could be strong. Vulnerabilities come in different forms of severities, different forms of CVSS scores, and all of those factor into the risk. On the other side, you've got the impact of a potential exploit. An impact of a potential exploit will be measured by the sensitivity of data that's returned in response for a particular API. It could be measured by spatial impact, which means which other APIs and how many other APIs does this particular API talk to. If you've ever seen a network diagram or if you've ever seen a flow map of your application, you've realized that there are some APIs that play that role of a broker, meaning they have a lot of consumers and they talk to a lot of producers, but they don't have a lot of neighbors. And they're not necessarily single points of failure, but they're definitely critical points of failure. And that's what we mean by spatial impact. If the spatial impact of an API is high, the impact of exploiting the API. And then thirdly, the business importance. Now, this varies from one industry to another, but we all have APIs that are more critical than other. If I'm running an e-commerce business, making sure that my checkout API, my payment API is more secure than maybe, my sign-up page and the APIs that are behind the help page is something that talks to the impact. So there are these factors. These are not the only ones. There may be others, but these are the most common factors on the likelihood and the impact side that we see day in and day out. So once you have a risk score of and a model to score every API in your environment for risk, you can apply policies that can make sure that none of these APIs are exploited and your risk posture is secure. You can make sure that these APIs are analyzed for any missing security errors. An out-of-the-box policy for a tool that can automate this is very easy. Another policy that we've seen very common for making sure that the governance model is in place is allow versions of the API enabled, and that's under control. There's no version sprawl, meaning that there are no 7, 8, 10 versions of APIs out there. You can limit the number of versions that are allowed to a fixed number, and the older versions are deprecated. Inactive users and inactive APIs are managed. This is time bound typically. So if you have a user in your system that's inactive for a certain time, you could turn off their account, you could suspend their account. Same thing for the APIs. Role controls are present on all APIs. This can be done through a gateway, or this can be done through a tool like Traceable, where we can enforce the right set of rules for different APIs. Ownership information is mandated. We've talked a bunch about this. API access requirements are met around authentication and encryption. All of us may want to enforce the highest standards for authentication, the highest standards for encryption for every single API in our system, but this comes at a cost and this takes time. So making sure that your high likelihood to be exploited APIs are authenticated and encrypted first. Your internet-facing APIs are authenticated and encrypted before you move on to the internal ones is a way in which you could use this policy. Any deprecated APIs and any shadow APIs are accounted for. We could set up a time limit for the number of days after which the deprecated API should start throwing up alerts. All of these policies can be enforced in a tool like Traceable, and to make this automated and to make this easy to do. Similarly, on the actioning side, once any of these policies fire, you could, depending on which policy fired, how critical it was, you could set up alerts, you could set up issue creation automation to score and prioritize. You could accept the risk and move on, knowing that you'll come back to it after a certain time. Or you could use things like rate limiting an API. Now, rate limiting is something that's typically done at the firewall level, but for modern day tools like Traceable, this is possible to do at an API level. You could go and rate limit access to an API, you could go and rate limit access for a user. You completely block the API, you could completely block them. There are many different types of actions possible. There are many different types of policies that are supported in a tool like Traceable. I just wanted to go through the common ones that we see our customers use day in and day out. So I've been talking for a while, but I wanted to summarize the whole discussion around API governance, risk-based governance, to these three key points. APIs have evolved to become the largest attack vector. Traditional visibility tools such as CFTPs typically don't take APIs into account. And if they do, it requires a lot of manual intensive labor to keep them up to date. API risk is different from application risk due to the nature of APIs. APIs are larger in number, they are more agile in nature. There are multiple versions, more versions of APIs that are present at any point in time. And we need to take those features into account when we think about APIs. Prevention is better than cure. Risk-based governance can provide you with a health check as well as a get well soon plan if you are starting out today, or if you were moving to an architecture where the number of APIs is going to grow exponentially. It's been great talking to you guys. Thank you for your time. Thank you.